Okay, this is the drawing on activity 3.5 about the duct which was twisted. They call it a twisted rectangular duct with a round corner. Okay, we're going to draw the development. Firstly, we have to remember with the triangulation, we need to know the true length. That's what we're gonna use in the development. We have the front view, we have the top view. So in front view, we are going to get the true length of all the vertical lines. And the top view, we are going to get the true length of all the horizontal lines. So before that, let's subdivide this. This all is almost a quarter of a cylinder. Okay, now we have the bottom rim. So from here to here is the bottom rim, from here to here is the top rim. Now we are going to number the top rim in top view. So this corner here is, we consider it 1, then we have 2, this is, we are on the top rim here, 2, we have 3, 4, 5 and 6. So it's about the top rim. So we can project them. You see that already 1 and 6, they are here, they coincide here, 1 and 6, and 5, is here in front view. We project it, 4 is here, 3 is here, and 2 is there. So you see that this is the shape of the top rim. Now let's go to the bottom rim. This corner, because the bottom rim is, the shape is the same. You see, we have almost a rectangle and a quarter of circle. The top rim, the bottom rim also is a quarter of circle and a rectangle. So this one and that one, the same. That's why they call it a twisted. All right. So this corner here, we call it A. This corner here, we call it B. Now we are dealing with the bottom rim. C. This point here is D. This point here is E. And this point here is F. So you can see that A, when you project it at the bottom rim from top view to front view, A is here, B is here. Now B, you see B and C, they are on the same line, so they coincide there. So FC and B on the same line here. Then you have D, this is point D, and there we have point E, and F coincide with A. So F and A, they are here. Like B and C, they coincide here. A and F, they coincide here. All right. So this is what we have in our top view and we show. So remember, numbers represent the top rem, letters represent the bottom rem. So this is what's going to help us for our development. So now, based on the theory of triangulation, we have to create triangles, right? So already in this quarter, we have already 3 triangles. Good. Now, how do we create the triangles? We'll take, if for instance you consider one number on the top rem, you have to consider 2 letters at the bottom rem to create a triangle. Then you'll find out the true length of that triangle. Then when you have the true, remember a triangle has got 3 sides. So if you have the true length of the triangle vertically in front view, horizontally in top view, so you can use those true length in your development, right? So how are we going to create our triangle? We are going to start, let's say if we start with a line, see if I consider the top rem. On the top rem I take 1 and 2 is a true length in top view. 1 2 is a true length in top view, so I have to consider it exactly as it is. Now because it's a true length, I have to take the dimension here from 2 to 1. I'm in top view, mark off here. So there here I have 1. You see I start from 1 to 2, 1. So this distance is the same as the distance here. I have 2. Now I have 1 and 2 in top rem. Then I consider A. You see 1 2 top rem, A bottom rem. That is a triangle. I have 2 numbers, 1 2 on top and A at the bottom. You see I have a triangle. So in this triangle, 1 2 A, 1 to 2 is a true length in top view. Now 1 to A and 2 to A, I have to get the true length. How am I going to get the true length? Because 1 to A is not a true length. If I join 2 to A is not a true length. Now I'll show the method. For us to get the true length, you see in top view, you extend the bottom rem, you extend the top rem, make it a bit bigger. All right, now perpendicular to both. Now from this line here, I'll check with my compass. I'll check the distance 1 to A. Take the distance 1 to A. One to A, yes. I will take it from the top view. Yeah. Then I'll get to see 1 to A. I'll take it from the top view. This is 1 to A. 1 to A. I want to get this distance 1 to A. For me to get the true length of it, I'll take the distance 1 to A in top view. I'll show it here. Then the hypotenuse will be my true length. So I don't have You don't have to take this distance 1 to A in front view. You take the distance 1 to A in top view, horizontal distance, you mark it off here. So this hypotenuse, that is the vertical true length, 1 to A. Then I'll take it. Now I mark off here. I strike this arc. This is 1 to A. Now I need 2 to A. So 2 to A, you see, is this distance here. 2 to A. 2 to A. Now I'll check. So remember this was the distance 1 to A. Okay, let's just write 81. Where is the eraser? So that you can remember. So this is the distance 1A1. Now is the distance 2A. Distance 2A. You see my triangle is 1, 2, 2A, A1. So 1, 2, we said is a true length, is already there. 1A, I took this distance here, mark off here. I have there, then with my, I joined from there, I have this hypotenuse with my compass from 1. Now 2A, I took this distance here, I mark it off here. You see, it's different. This was 2A, A1. Now A2 is there. So this is for A2. That was for A1. Now I check the distance. So this is the true length. Now from 2, I mark off here. This is the point A. Right? Then I need now, this is, I can join 1 to A, 1 to 2. Now I'll work out. You see, I have 2 and A in top view. Remember, in top view I start 1, 2, A. Now I have 2 and A, I need B. So I have to find the position of B. So 2 is already there, A is already there. Now I need BA. Now you see that BA in top view is a true length. Is a true length because both they are on the bottom rim. It's different from one top rim, a bottom rim. That's where we find the true length. 2 top rim, a bottom rim, we find a true length. 1 top rim, 2 top rim is already a true length. We use it here. The same B and A, both they are at the bottom rim. So this is a true length. BA is a true length. From A, I struck there, my arc. Now I need 2B. Now remember, 2 is on top, B top rim, B is at the bottom. Then I have to find the true length. I'll take this 2 top rim, B bottom rim. I mark off here. See, this is B, B and 2. then this I join there. This is the true length which I need, because I'm working out one point at the top rim, another point at the bottom rim. Okay, now from 2 intersect here, that is my B. So my point B is here. Now I can join them. Okay, you see I have 1, 2, A, B. Now I need to add one more letter, C. You see, now I'll have 2 is on top rim, C is at the bottom rim. You see, 2 is on top rim, C is on the bottom rim. But on the top view, you see all of them, they coincide here. So 2 top rim, C bottom rim, B bottom rim, 2 top rim. I have another triangle. So I have already 2 top rim, B bottom rim. I just need to add C. Now C, BC, they are on the bottom rim. So I have a true length. So BC is a true length because the 2 on the bottom rim. So BC is true length. Like here. Now 2C. 2C, because they coincide, you see 2 and C. So actually this distance here is a true length for 2 and C. You see, it's a true length, right? Because 2 and C is on the quarter cylinder. You see, this is a quarter of a cylinder. So 2 and C, they coincide. So 2 and C is a true length. It's the same as this distance here. So this is the true length for 2 and C. You see, this is the same as 2 and C in front view. Now from 2, now I need to extend BC so that the 2 arcs will intersect. Okay. So this is C, 2 and C. This is the true length from the top view. You see 2 and C is true length in front view, and BC is true length. BC is true length in the bottom. All right. So now from C I need D. Or how am I going to get D? You see that here already 2 and C. I have 2 and C. I have 2 and C. So from 2 and C, 3D, 2C, 3D, 4E, 5F is a cylinder, quarter of a cylinder. 2 top rim, C bottom rim. 3 top rim, D bottom rim. 4 top rim, E bottom, sorry. 5 top rim, F bottom rim. All right, so it's a cylinder. All right, so in terms of cylinder, it should come easier for me if I can just extend this line here, BC. There is a method that you can use when you have cylinder. You can still create triangles or triangular shapes. You can seal between, but it will take much time for nothing, because I know that in this place that must be parallel because it's a quarter cylinder. So there I just take the distance here, CD, D, then it will be D, E, then E, F. So I have D, E, F, F. All right. Now parallel. Parallel. I still have the same because both sides the distance is the same. Then I have 3, I have 4, I have 5, 3, 4, 5. So this part here is actually part of the quarter of the cylinder. So this is the quarter cylinder. This is the quarter cylinder. This is my quarter cylinder. Okay, I'll make it big later. Now, let's go from top. I have 5. I want to have 6 on top. Then I will go to F. You see, 5, 6, F is a triangle. 5, 6, F is a triangle. 5 and 6 is a true length here because they are on the top rim. So 5 and 6 is a true length. I will take it there. 5 and 6 top rim is a true length. 5 and 6 top rim is a true length. I have my 6 here. Then I will join to F because F is already there. Remember I say 5, 6, F. All right. 5, 6 is a true length. All right. So I have my 6 there. I join the 2. I join to F. Okay, so every time we add one number or one letter to have a triangle. Okay. So now I need 6, 1. I want to add 1. So the triangle that I'm creating is 1. I want to add 1 here to end up, because you said we start 1, 2, 3, 4, 5, 6. I have to finish with 1 again. It's here 1, 2, 3, 4, 5, 6, 1. We close. So we have started, we have to close again. Right now 6, 1 again is a true length. You can see 6 and 1 is a true length. I can take it. 6 and 1 is a true length. I mark off here. So I take 6 and 1. I'm working on the top rim. Is a true length. This is my arc. Now I need 1F. All right, so we have 1F. You see, 1 is on top. F is at the bottom. Can you see? 1 here, we have 1 and 6, they coincide. F is there. So 1 to F. You see, I'm looking for this true length 1 to F. So I'll take in the top view 1 to F. 1 to F. Join this 1 to F. So this is the line I need to get a true length. So 1 to F. Somewhere here. 1 to F. Actually it must be the same as, yeah, A. So 2A, A1 to F, it must be the same. See, it's just made based of small inaccuracy. It must be the same. So A must be on the same. So that means 2A and 1F. We have already that hypotenuse here. So we say that here 2A is the same F1. So we take the same, the same. Now from F, they must intersect, right? So this is our 1. Now we can join 6 to 1. Join 6 to 1. Right? Now we have F61. Now here we have A, B, C, D, E, F. So we need A. A, B, C, D, E, F. Then we come back to A. So we need here A to close. So now how are we going to get A? We have 1 FA. 1 A, N and F coincide. So we have 1 FA. 1 on top, F at the bottom, A at the bottom, right? So we need the distance FA. See, the distance FA is a true length because it's the bottom rim. A and F is on the bottom rim, so it's a true length. This distance is a true length, bottom rim. So from F, we mark off here. This is the true length. Now we need 1 to A. 1 is on the top, A is at the bottom. So we need to take 1 to A. We add it already here. 1 to A is there. You see, 1 to A is there. Then we take this. It's the same as this distance here. So 1, you can even take them because you already have 1 to A. So instead of coming again here, you can just pick up this distance, you bring it here. It will be the same. So this is A to close the development. Then we have closed our development. So in terms of philosophy, focus mostly on the top view. Focus here, you focus here to get the horizontal true length, like A, B, C, D, E, F, A. All these distances are true length. 1, 2, 3, 4, 5, 6, 1. So all 1 to 2 is true length. 2 to 3 is true length. Now when you have to create a triangle from 1 point on the top, 2 points at the bottom. Now when you join the top to the bottom, now take the distance on top view and bring it here. So the hypotenuse gives you the true length which will bring here. You can see, for instance, you see 2 is top length, top rim, B is bottom rim. So if I join 2 to B, in this case, because they coincide, you see 2 and C, they coincide in top view. But in front view, they don't coincide. You see, we have 2 on top. Now they are perpendicular to our directions here. So it's a true length. That's why we have a true length here. Now when we have, for instance, 1 to A is not a true length in this case because they don't coincide. You see, 1 is there, A is there. Then you take 1 and A in, because 1 is top rem, on the top rem, A is the bottom rem. Now when you change 1 to A, you have to bring that distance with your compass, you bring it here. Then you take the hypotenuse. That is the true length which you bring on the development. All right. So this is our drawing done. So try to go through it. Thank you.